to resist the effects of the sun. The desert devours everything except stone, cementitious products. Doesn't matter what kind of wood, doesn't matter what kind of stain, doesn't matter what kind of vinyl. It doesn't matter if your fence is not made out of either masonry or steel, it's going to go bad in an alarmingly short period of time. So even something as simple looking as an 8-foot wall, hundreds of feet long, required some real engineering. The first engineer to weigh in was the geotechnical engineer. He had to establish soil bearing capacities. The soil bearing capacity is information the structural engineer has to have to determine how wide the footing needs to be to hold the load, not just of the wall, but of the wind loads and overturning moments, because this wall is only braced at the corners. Where you make a 90, where the direction of the wall changes, that's the only place that the system is braced inside the system. So in the middle of these long spans, the resistance to getting tipped over has to come from the footing. The width of the footing, the location of the wall on the footing, how far it's in the ground. So those things are information that the structural engineer is dealing with based on what the geotechnical told him to make a wall system here that is always going to look as good as it looks when it's new. The term mason applies to anyone, or can apply to anyone, who works with a cementitious material or a brick, concrete, grout, plaster. Anything that's cementitious, that's applied or finished with a trowel, can be thought of as being done by a mason. But there's specialization in masonry. On this job, you're going to see guys who specialize more often in placing and finishing concrete, i.e. striking off the footing, i.e. putting the footing in place and pouring out of the truck. And then you're going to see guys come in who specialize in laying block. Now sometimes people will be able to do both these things with really good facility, but most of the time the demand of establishing muscle memory means you're only going to get really good at one of the aspects of a craft like this. Muscle memory grows with practice. There have been extensive studies done that seem to indicate it takes about 10,000 hours to really get seriously proficient at something. These fellows have way more than 10,000 hours in learning to lay this block. Every little bit of that process adds up to either more or less productivity at the end of the day. If you're picking up 5 or 10 seconds on each block you lay, by the time you've laid a lot of block in this wall, you're going to be either a lot further down the wall or behind in your productivity. So if you're learning a trade like this, if you're learning skill, concentrate on shaving time off of your effort. One of the biggest ways to save time in every aspect of construction is in handling and staging the material. In fact, 80% of construction and construction productivity is in handling material. Construction is all about picking up materials and putting them in place. And so the way that material is staged is the place you have the most control over productivity. You'll notice that the block is located, the mud, the mortar is located, the rebar is placed to minimize handling. You only want to pick this stuff up once. And a mistake in staging, a mistake in spacing the blocks of the pallets of block, a mistake in the location of the mixer can really multiply unnecessarily the amount of labor it takes to get this job done. Rarely do you lay a block wall on a site that is perfectly level. Mother Earth is sloped in every direction except on the Bonneville Salt Flats, okay? But in this site, there's, I don't know, probably a 2% slope across the whole site. But you want your block walls to be level. That means the footing is going to necessarily have to step to follow the grade. The steps need to be in the increments of the block, either 8 inches or 4 inches. So as they were digging these footings, they had to step the bottom elevation of the footings and then put a little bulkhead in to make a step at the right location so that the top of the footing also stepped, always remaining level, so that the base course on the wall could be level and the wall itself would be appropriate. So level is important. Steps are part of figuring out how to do the preliminary work for the block wall. And one of the things that I have learned over the years that these guys are illustrating, and that it kind of went against the grain for me, and I wasted a lot of time. I used to try to set the bulkheads for the steps at the point that the bond would happen on the brick. That's a waste of time. When you're setting bulkheads for steps in the footings for a block wall, just throw the bulkhead in, and then the mason will cut the block to fit the condition of the step. You don't have to build the step to match the bond on the block. One of the challenges when you're dirt bank forming a footing is that you have to have clearance from your rebar to the dirt. You do not want the rebar that's inside of your footing to be in contact with dirt, because then you have a rust issue and the rebar will degrade over time. So typically you need, a couple inches, maybe as much as 3 inches of concrete between your rebar and the dirt on all sides, on all ends. And with dirt bank forming, sometimes that's a bit of a problem. Not only is rebar placement very specific in the footing, but when it comes out of the footing, the verts that come up in the air in a block wall are even fussier than in a cast-in-place wall, because the verts have to hit inside the cell of the block. So when those masons are slamming these blocks in here, they're not having to hickey or bend or distort those rebar verts into the cells as they have the challenge of slipping these over the verts while the mud is on them onto their bed joint without tearing the world apart. So the rebar verts have to come up in the right spot. These guys did a great job of making that happen with really minimal form work, minimal messing around. They know how to do it. This is a pretty sturdy footing, 30 inches wide, 12 inches thick, and almost 1,400 feet long. It's a lot of concrete. If you're interested in footings like this, if the distribution of forces that a footing is accomplishing, the forces of buckling or sinking or overturning all being dealt with by the concrete and the rebar in a footing, if that's interesting to you, check out the videos on our Spec House series. I had a couple of footings up there that were very technical. Well, semi-technical. One in particular, very heavy duty. 2 mats, top suspended mat, lots of verts. If you're interested in concrete footings, we've got some other videos that you'll probably enjoy. As you've been looking at this wall, you may have noticed these vertical lines. The bond on this wall, this is common bond or running bond, where each joint happens halfway underneath the block above it. That lines up the cells. It's not stacked bond. That's a whole different conversation. But the bond is interrupted at these control joints. What's up with that? It's crack control. It's just like control joints in a sidewalk or a driveway or a concrete retaining wall. This is to try to force any cracking that might happen because of soil movement or for whatever combination of reasons. It tries to isolate the crack at each location, and they're 20 feet apart. Masonry as a trade is a fascinating thing. It's been around a long, long time. And today, 21st century construction nomenclature, when you say mason, it can encompass a lot of different sort of subset skills or craft. You got cement masons or concrete masons that are primarily finishers, concrete finishers. You have block masons, stone masons laying natural stone products, brick masons, and it's somewhat splitting hairs because most of the guys that can do one can do the others, although it tends to sort of invite specialization like framing. There are guys who specialize in roofs, there are guys who specialize in sheathing. So in masonry, what you're looking at here are block masons, and they're putting in a CMU wall. That's a concrete masonry unit. Used to be called cinder block because of the material that is used as the aggregate, or that was used as the aggregate. They are more uniform now, more testable, more structurally predictable, and they're called concrete masonry units. Unlike some of the other masonry crafts like stone, if you're laying up a stone fireplace or a stone column, you have the variability of Mother Nature's sizes and shapes and textures and colors. And so a substandard job might be harder to identify by a novice. I mean, if you don't know anything about stonework, you might walk by an excellent piece of stonework and not identify it as excellent. Or you might walk by a sloppy piece and you might not notice it. But on something like this, anybody can tell when it's not straight. Anybody can tell when the head joints or the bed joints aren't even. And so it's easy to be critical. These guys are doing a nice job on a high volume project. So with the footing in place, cleaned up, with the block carefully staged in the right location, the right distance from the wall, and the right quantities and the right centers, with all of the supplies where they need to be so the work can start, now it's time to put down your starter course, your base course, and it's the hardest course in the whole wall. Think of it. You're placing these blocks and the mud down at the height of the soles of your shoes, and then you've got to set them there to a string, get the head joints in, strike it off, and when you walk away or when you start coming up with the next courses, you got to know for sure that thing is where it goes, because if that thing's wrong, it's going to take you quite a distance to get the wall back to square, plumb, and true. So that first base course is painful. Once you start getting up about knee high and coming on up, it's just not bad. So the first lift on this wall is 4 feet high. A lift is the first vertical distance that you go in, how would you describe this? It's the first assault. And the first assault on this wall is 48 inches tall. At that point, they stop and just keep moving laterally 48 inches high so that the inspector can come back and look down inside the cell. He takes his flashlight, he verifies that the rebar is where it needs to be, that you don't have too much mortar squishing to the inside and reducing the size of the cells, that you have the right amount of ladder mesh. Here's a piece of ladder mesh. That you have ladder mesh installed correctly, providing some reinforcement every 16 inches. All of these things have to be according to the specifications, or he can't pass it, and the wall will not handle the forces that it has to handle appropriately. So once the first lift is in, it's been inspected, then it's time to grout the first lift. There are 3 different cementitious mix designs that are going to be included in the structure of this wall. I'm going to refer to them as mix designs. What I mean by that is recipes. There are 3 different recipes of concrete that are used in this wall. The one these guys are using right now is the mortar. It's a spec mix. It's made by Spec Mix, and it comes in bags, and it's perfect. It's very simple. It's cement, Portland cement, lime, and water. Each one of those things has a job to do in the recipe. The Portland cement is what causes the reaction. It, in a way that I won't even pretend to understand, triggers a reaction where silica crystals begin to grow and get a hold of each other and get a hold of the rocks, or in this case the sand, and they make little structures that get hard. There's a very thin piece of mortar. That's pretty hard. And see how thin it's squished? I mean, that's only about 5/16 of an inch. And it's hard, and it does its job. It's kind of like glue, but it's not that hard. Here is some mortar. It was a bag that got wet. You can see the bag is still sticking out of there. Now it's hard, but you wouldn't want your driveway made out of that, would you? Now the reason it's only kind of hard is because there are no rocks in there. And rocks are what give concrete strength. Look at the problem it would be if there were rocks in there. You couldn't set those bricks down, those blocks down to a uniform height. Now think about the footing. This material right here is some hard rock concrete, 3/4 inch aggregate, that was left over out of the footing. You can see there's some good sized rocks in there. Okay, that's a lot harder. So think of the mortar as glue. It holds the blocks where they need to be for a period of time until the next very important step happens, and that is the grout is put into this wall. So in this corner, the strength of these 2 walls to resist overturning is coming from the corner. I mean, you can't turn this wall over because this wall's tied into it and vice versa. But by the time you get down to the middle of a 550-foot wall, you are a long ways from the corner, and the strength needs to come from somewhere else. In this case, the strength is not coming from the mortar. The strength comes from the grout. The grout is the 3rd mix design, the 3rd recipe. And it is stronger than the mortar, not as strong as the footing, but plenty strong for what it needs to do. And what it needs to do is fill every 40 inches. There's a rebar vert, number 5 bar, that comes out of the footing, comes up inside the cell. Another vert is dropped down from the top so that they overlap, and then the whole cell is filled with grout. It has 3/8 aggregate in it. Those rocks are gripped in the hydration process and provide a vertical beam. When that gets hard and encases the rebar, it acts as a very, very strong spot on this wall to resist any bowing or bending or overturning. And when you put one every 40 inches down 500 feet, you've got a lot of beams standing there, don't you? Now, the third component to the strength of this wall is the bond beam, which occurs in the top course. The top course of this wall is composed of bond beam blocks, where the webs are knocked out so that rebar can be run continuously down the top of this wall and then grouted into place, creating a concrete beam at the top, tied to the concrete beams every 40 inches, which makes a very, very strong 8-inch CMU wall. Now, as you can tell, there's been a lot of engineering, a lot of concrete, a lot of material, a lot of work, a lot of headache, a lot of money, and it might seem like overkill to you. Think about the alternative. There's some money that is way too expensive to try to save. 6-inch block, no head joints, very few verts, like almost no verts at all. Anyway, do it right and you're never sorry.